Hi everybody, my name is Nitin Rajmohan. I'm a co-founder at Akeana and also focus on the hardware and systems engineering. So Akeana is a RISC-V processor systems and interconnect IP company, and we provide different IPs for RISC-V market. And today we're going to cover one of our high performance cores, the Akeana 5100 series. So the Akeana 5100 series is an out of order core. It's a 64-bit RISC-V ISA, RVA23 compatible, and it's got hypervisor and full vector implementation. It's got a 6-wide instruction dispatch, 12-stage out of order, L1 D cache, 64 KB, private L2 cache, 256 KB. It's got a L3 cache, 2 MB, hypervisor, virtual address 48 bits, physical address 33 bits, physical memory protection, instruction and data TLB 64 entries, second level TLB 2048 entries. It's got the full RISC-V vector extension version 1.0 with a 128-bit VLAN and DLAN, and it's got vector and scalar cryptography extensions. So for today's demo, we're going to be running an Akeana 5100 core on a HAPS-100 system, FPGA system. It's running at 40 megahertz design speed, and we're going to showcase the full range of capabilities and the maturity of the design in this demo. So the features that we are targeting, the RVA23 features, which is hypervisor, vector, and related functions. So the demo itself runs multiple applications. We got a host Linux OS, that's the hypervisor that's running. And under this host OS, we'll be running multiple vector applications. These are benchmarks like FFmpeg. FFmpeg is a benchmark of the multimedia framework. DGEM, another benchmark that measures the performance of matrix multiplication. Snappy, another benchmark. It's a fast data compression and decompression library in C++. And OpenSSL that implements SSL and TSL protocols. This particular benchmark will stress the vector aspect of it. Then we'll be running a Nginx web server along with these benchmarks under the host Linux OS. And in addition to it, we'll also have two guest OSs that will be running the top processes so that we can monitor what's running on each of the guests. Let's look at the hardware. The hardware is a HAPS-100 FPGA platform running at 40 megahertz. For this demo, it's a single core Akeana 5100 with a shared cache 2 MB, and it's got a UART, an interconnect, and DDR. It's also got a PCIe interface where you can connect a NIC and network into this design. So that's about the hardware. Now let's look at the actual demo. So as you can see in this window, you can see four different quadrants of the window. On top left, you can see Akeana web page. Now this web page is basically connected through a Akeana web server running on the FPGA. So you can see the Akeana logo there. Now below left, so this is where we are running the host OS. And here we are running the different vector applications that we talked about earlier. So as you can see, they're all running and printing out numbers. Now let's go to the right side of the windows. So you got top and bottom. So these are the two guest OS that are running on the right side. You got a guest OS 1 on the top and OS 2 on the bottom. Right now they are running the top process monitor, but you can see they're both running the top process monitor. Now all these applications and the OS are running simultaneously at the same time on our FPGA, which is emulating our Akeana 5100 core. So the Akeana 5100 that we demoed here is part of the Akeana 5000 series cores that provides industry-leading RISC-V ISA cores. Performance scales up to 25 SPECint 2006 per gigahertz in a single thread on our highest end Akeana 5300 line. And we also support advanced features like security, RAS, telemetry, functional safety, and all of these cores. Scalable performance with multi-core cluster and support for non-coherent and coherent multi-core fabric. All these are additional IP offerings that we provide with our core. And this basically enables next generation compute arrays for mobile, automotive, and AI data center.